Hey everyone, in this video we will discuss section 4.3, which is about polynomial inequalities. This will continue working on our understanding of polynomial graphs, but it's also going to provide us with an analytical way to consider the graph. This video is also going to go over a process that we're going to use quite a bit in our calculus work next year, so it's really important that we learn it now and we learn it well. So, first things first, a couple of ways that we're going to look at it. Okay, so when we're looking at f of x, okay, or f of x is greater than 0 or f of x is less than 0, we need to consider graphically what all of that looks like. So when we write f of x, we're referring to the y value of the function. Notice we often write like y equals f of x. That's literally saying that these two are equivalent. So this is our output, whereas the x was our input. When we write f of x is greater than 0, we're meaning that the graph of f of x is above the x-axis, or it has positive y values. Okay, the outputs are bigger than 0. Whereas f of x is less than 0 means that the graph of f of x is below the x-axis. Okay, it's the negative y values. So in our first example, we have a function f of x that's graphed. So first it asks us, where does f of x equal 0? So that's asking, where are my y values equal to 0? Well, I see that we do have 3 zeros. -3, -1, and 3. Okay. Next it asks, where is f of x greater than 0? So that's where my y values are above the x-axis. So if I'm looking at my graph, I see that we have this region and we have this region here. Okay, so when we write our answers to polynomial inequalities, we are going to use interval notation, and we do want to take into consideration if it says greater than 0 or greater than or equal to 0. So because it just says greater than 0, we're not going to include the x-intercepts of where it touches. We're just going to include everything that's directly above that. So we have -3 to -1, and then my union sign, we go from 3, and then I'm going to assume that this graph keeps going and it goes to infinity. Okay, our next one says where is f of x less than or equal to 0? So that's where my y values are below the x-axis, or because it has that equal to, it's where it's touching it. So I have this region here and this region here. So it looks like this is happening from -infinity to -3, and because we have the equal to sign, I'm going to include -3. And then this happens again from -1 to +3. Okay, so that's how we can look at the graph of f of x, or a graph of a function, and determine the inequalities that way. However, I know that you all are pretty comfortable with graphs, but we do need to learn kind of a new way to do this. So we can solve nonlinear inequalities analytically. To do so, you must create and interpret a sign chart. Oh, meant to highlight that. Let's try that again. A sign chart that represents the function. We're going to make sure that we write our answer in interval notation and consider the endpoints. So the whole part of a sign chart is we're going to basically construct a graph of a function, but we're not going to do so like actually by drawing a graph. Okay, we're going to do so by thinking about some values on the graph and whether they're positive or negative. So, for instance, in example 2, we're going to solve this factored polynomial, and we want to know where it's greater than or equal to 0. So basically what this question is asking is, where is this polynomial above or touching the x-axis? Okay, and we're not going to make a graph for it. We're not going to graph this on a calculator. We can do so analytically. So the first thing that we need to do, just like what we saw from above, is it's really helpful to know where the zeros are, so that way we know what's going to break up our function. So finding the zeros of this polynomial, and I'm going to set each factor equal to 0 and solve. So for instance, the first one, I'm going to get that x is equal to -1/2. The second one, I'm going to get x is equal to 2. And then for the third one, even though I have that multiplicity of 2, I know that that 0 that's coming from it is going to be x equals, 4/3. Okay, so for this, since I know that those are my zeros, I know that that's gonna be what splits up my function. So making a sign chart, I'm going to go ahead and I'm going to draw a line. It's helpful if it's kind of big. Might even make it slightly bigger. Okay, and I'm going to basically make a number line using my zeros. So I have a 0 at -1/2, I have a 0 at 2, and I have a 0 at 4/3. Okay, And so what we're going to do is we're going to take some test values, and I'm going to find test values in between the 4 different regions that we have. So my first test region is here. Okay, and I might use a test value of -1. I know that's within the region. My next test value is here. I might use 0. Okay, whenever possible. 0 is a really nice one to use. My next test region is going to be in here. So between 2 and 4/3. Let's see. Okay, well, first of all, hopefully you caught this. 4/3 is less than 2. Okay. I don't know why I said that. Okay, this test region, let's see, we're going to have 1.5. And then this one over here, let's just use 3. Okay, you can use any numbers that you want. It doesn't really matter. I could have used 100. Still is going to work out. Okay, so from here, within these test regions, again, if I'm looking up at my graph that we had from up above, we really had 4 test regions before. We had like 1, 2, 3, and 4. So what we're going to do without actually having to graph it is I'm going to plug in my test values, and we're going to determine what the sign of that number would be. Okay, if it's positive, I know that my function would be above the x-axis. If it's negative, I know that it's going to be below. Okay, so first let's plug in -1. And here's the thing, we don't actually have to calculate what that value is. I just want to know what the sign of that number would be. So plugging it in to my first factor, okay, I would have 2 times -1 plus 1. Okay, so 2 times -1 is -2. -2 plus 1 is still going to be negative, so I'm going to put a negative here. Okay, now plugging it in for my next one, okay, I would have -1 minus 2, which is -3. So that would be a negative number. Okay, plugging it in for my next one, okay, I would have 3 times -1 minus 4. Okay, that would give me -7, but the whole thing is being squared. So because my quantity is going to be squared, this factor, this portion, will always give me out a positive number. So what we have is a negative number from the first part times a negative number from the second part times a positive number from the third. That's going to ultimately be a positive number. So I know that within this region from -infinity to -1/2, my function is above the x-axis. Okay, I'm going to do the same thing for 0. Okay, so I'm going to plug it in 2 here. So 2 times 0 plus 1, well, that's just going to be 1, so it's going to give me a positive number. 0 minus 2 is negative. And then I know that this last factor is always going to be positive. Okay, so I have a positive times a negative times a positive. That's going to be a negative number. So I know that between -1/2 and 4/3, I should be below the x-axis. Okay, going to plug in 1.5. Let's see, 1.5 times 2 is 3. 3 plus 1 is 4, so that's going to be positive. 1.5 minus 2 will be negative, and then the last one is always positive, so this will be negative. So we're still below the x-axis. And then plugging in 3, let's see, that's going to be positive for the first one, positive for the second one, and then positive for the third one. So my region from 2 to infinity should be positive. Okay, so this question was asking where our function was greater than or equal to 0, and so I can see that my regions where this is true, okay, the -infinity to -1/2, and then from 2 to infinity. Now, since this question also has an equal to, I also want to make sure that any place I can, I'm including a 0. So I know that I'm going to include my 0 at 1/2, I'm going to include my 0 at 2, and then even though we didn't have a positive number in my in-between regions, I am going to include the 4/3 because it is equal to 0 at 4/3. So the answer to this question and how we would write it, let's see, I don't have a good place to put it. Put it right up here. I'm going to say -infinity to -1/2. Okay, bracket because I want to make sure that I include that 0. Then union, then I'm going to use the set notation for the single value of 4/3. And then 2 to infinity with a bracket. Okay, so this is the answer to this inequality. Now, one thing that you can kind of do, you can kind of think about what the graph is going to look like to just confirm what your sign chart says. So like for instance here, I know that this is going to be a quartic polynomial, so my end behavior should both be facing upward. I do have a positive leading coefficient, okay, so it should look like this. I know that on my -1/2 and my 2, I am going to cross the x-axis, so I would dip from above to below here. Okay, I know that at the 4/3, since we have a multiplicity of 2, I would bounce, and then I'm going to cross again and then keep going up. Okay, so like you can check and see what the function looks like. However, it is very important that you are not skipping this part. Okay, that is not something that's not optional. You can use the graph to check it, but ultimately, like, I will be looking for those signs because that's going to help us out a lot next year. So it's good for you to learn now. Okay. Okay, last example we're going to look at, same thing. We have another polynomial that we're going to look at, and this time we're looking to see where it is less than 0. So we are trying to figure out where this is below the x-axis. All right, so again, I know that I need to find my zeros. Okay, I can easily get x equals -1 from the first one, but I see that my second part actually hasn't been factored all the way. So either A, we're going to factor it, or B, if we can't factor it, guess what? Quadratic formula time. Okay, but I do think this one's going to factor. So this will be x minus 2 times x minus 1. Okay, so we should have, this first one should be x equals -1. Hopefully you caught that. We should also have x equals 2, and then here's our x equals +1. All right, so drawing my sign chart, I know I'm going to have -1, 1, and 2, and this time I did put them in the right order. Okay, so choosing our test value, so I might use -2, 0, 1.5, and 3. All right, so plugging it in, so putting it in for my first vector, -2 plus 1, it's a negative number. -2 minus 2 is a negative number. -2 minus 1 is a negative number. Okay, so this should end up being negative here. Going in for our second, for 0. 0 is nice. That should be a positive times a negative times a negative. So that's going to be a positive interval. Okay, putting in 1.5, I should have positive, negative, positive. So this will be negative. And then for 3, I have positive, positive, and positive. All right, so the question was asking where we are below the x-axis. I'm going to look at the negative regions. So it looks like I have a negative region here, and I have a negative region in between 1 and 2. Okay, and because it doesn't have a less than or equal to sign, I know that I'm going to want to make sure I use parentheses. I'm not including my zeros in this. So my answer is going to be -infinity to -1, parenthesis, union 1 to 2. All right, okay, we're going to finish up the rest of the notes when we go to class. Hopefully this will throw back to a couple of things that we've talked about before in this class. The good news about the inequalities and the sign chart is we are going to see them a little bit later on in this unit again with rational functions. And again, I promise you that is where the sign chart is going to be super important also next year. So that's all I have for this video, and I will see you all later.